Hello everyone and welcome to the channel. This is the video I am uploading before the NSM exam, numerical and statistical methods. And in this video we will be seeing a quick review of bisection method, Newton-raphson method, Gauss elimination with partial pivoting, Gauss-seidel method, Thomas algorithm for tridiagonal matrix from unit 1, and Taylor series method, Euler method, Runge-kutta fourth order method, simultaneous equation for Runge-kutta second order method, simple LaPlace method, and parabolic explicit solution. We will be seeing formula and one important numerical from all of these topics, and after that towards the end we will also see a flowchart. So if you haven't yet subscribed to the channel, please subscribe, because I will be uploading the videos for all the subjects like HMT, DME and MSc, mechatronics, and maybe data science honors also. I'm not yet quite sure. So without wasting much of our time, let's begin. So we will begin with the very first topic, that is the bisection method. In bisection method you have to take two initial guesses, that is x1 and x2, and the initial guesses x1 and x2 should be in such a way that their functional values should have opposite signs. So what are functional values? Functional value means value of f of x1 and value of f of x2. If f of x1 is positive, f of x2 should be negative, or vice versa. And the convergence means, to prove it, it simply means that the multiplication of these two should be less than 0. If that is the case, then we can go ahead and solve this. We calculate value of x3, which is x1 plus x2 divided by 2. And what do we do with that x3? We take that x3 and then we replace it with x1 or x2. We will see how and why we replace it with x1 or x2. So we'll see this one numerical. It came in exam for 6 marks once, so I think that it is important. This might come for the exam. So let us go ahead and see what it is. So they have said a chip tool interface temperature model is expressed as below, and this is the equation given, where T average chip tool interface temperature, V cutting speed, and F is feed. Okay, no problem. We will just write it down over here. T is equal to 134 V raised to 0.42 into F raised to 1.5. Okay, and then they have given value of T, which is 900 degrees Celsius, and value of feed, which is 340 minute, and value of V is given, cutting speed value of V is given 340 meter per minute, and value of F is not given. We have to find that out, find maximum feed. So that is what we have to find out. We'll substitute these value in this equation. So that is 900 equals 314 into 340 into raised to F raised to 1.5. So we will replace F with X, so this will look more familiar. Okay, so this equation, after solving this equation looks like this: 0414 into F raised to 1.5 minus 900 equals 0. We already replaced F with X, so that is X raised to 1.5. So towards the next part of the solution, how we are going to do it, they have given us two initial guesses, which are 0 and 0.5. So our x1 equals 0 and x2 is equal to 0.5. So now we will calculate f of 0. So we will put x equals to 0, and that turns out to be 3632.0414 into 0 raised to 1.5 minus 900. That is minus 900, and it is negative in sign. Okay, and then we go ahead, we calculate this f of 0.5, and that turns out to be 384.12, which is positive. So our initial guesses, whatever they have given, is absolutely correct. We can go ahead, but what we can do is now we do the first iteration. We give the heading here iteration 1. They have told us to do total of 5 iterations. We will do the first iteration, x1 equals 0 comma x2 equals 0.5 and x3 equals x1 plus x2 divided by 2. That turns out to be 0.25. Now we calculate f of x3 as well, and that is 3632.0414 0.25 minus 900, and that is minus 446, which is negative. So what we do over here is we just substitute x3 in place of x1. So our x3 is new x1, because value of this, like functional value, is negative. Functional value of x1 was negative and it is negative. So we can replace them and do the iteration 2 again. And then iteration 3, 4 and 5th would be the last iteration. Whatever value comes at the end, that is our final answer over there. So whatever value of x3 comes over there, that is our final value. Then there's no need to substitute or recalculate or anything. If they have told us that 5 iterations, then we have to do 5 iterations. If they have told us for the accuracy, then we have to solve it until we get the required accuracy. So if they have given the accuracy 0.001 till 4 decimal places, so you have to solve until you get this accuracy. The answer should be less than this. Then and then only you can stop solving. I hope this is clear. Next we are going to see Newton-raphson method. For Newton-raphson method, we have to find the real root of this and correct up to 5 decimal places. So they have given us the accuracy ED equals 0.00001. I won't be solving till the end. I will be just explaining how to do it. They have given the initial guesses x is equal to 2. So for Newton-raphson method, we require the derivatives. So x log 10x equals 1.2. We solve it, x log 10x minus 1.2 equals 0. And after that we will just simplify it. Log ex log e10 is 1.2. So after solving this, we get 0.4343 log ex minus 1.2. And after, this is our f of x. This is our f of x. Our f dash of x will be 0.43 after taking its derivative. 4343 x 1 by x plus log ex equals 0.4343 1 plus log ex. Okay, then we will again take its derivative. We'll do double derivative, and that it will be 0.4343 0 plus 1 by x equals 0.4343 upon x. So as our initial guess was x is equal to 2, we will substitute x is equal to 2 in this, and in this. So I'll directly tell you guys the values. Minus 0.5979 is equal to f dash equals 2 equals 0.7353, and f double dash equals to f double dash of 2 equals 0.21715. And now we again have a convergence formula, phi of x naught, that is f of x into f double dash of x upon f dash of x whole square. So that formula we have to use over here and we have to substitute these values f of 2, f dash of 2 and f double dash of 2 in this formula, and we have to see. So I'll directly tell you its value. It's 0.2402, and that is, its mod is obviously less than 1. It is 0.2, so it is obviously less than 1. So we know that this is going to converge. So we finally calculate the value of x1. x1 is x naught, that is our 2 right now, minus f of x naught, that is, the value is minus 0.5979 upon f dash of x naught, and that is, f dash of x naught is 0.7353. So after calculating it, the answer turns out to be 2.8131375 for x1. Now this x1 will become, so our accuracy is this, so this answer should be less than this, but that is not the case right now. So we will again have to do another iteration where this is x naught, so x1 will become x naught, and then you have to substitute again value of x1 in this, and again find out convergence. Once again find out value of x1 considering this as x naught, and solve until you get this accuracy. I hope you guys have understood. We'll move on to the next problem. Next we are going to see a Gauss elimination method. So we have to solve this using Gauss elimination method. So first we'll write a matrix AXB, so where A is this 1 3 5 3 2 4 2 1 1, x x1 x2 x3, and B matrix is 2 7 and 4. Correct. So augmented matrix, we will put it in the augmented matrix. Augmented matrix A 1 3 2 3 2 1 5 4 1, and there's a straight line over here, 2 7 4. So now what we have to do is we have to make these two elements as 0. Actually generally this is the pivot element and this is made 1, but right now it is already 1, so we cannot again make it 1. It's well and good, it's 1, so let it be, and this we will make 0. After this is made 0, whatever this value is, we make that value 1 and the value below it 0. So it will look like 1 1 some value 1 1 some value 0 0 0 some value. Okay, and then we solve it finally. Let me just check. No, I haven't kept place for it over here. So I hope you guys have understood how do we do row transformation. I'll show you one how we convert this to 3 to 0 and 2 to 0. So this is the row 2. So we just say row 2 is row 2 minus 3r1. So if you multiply this row with 3, so that is 3. So this becomes 0, and r3 is r3 minus 2r1. So this is 2, so this becomes 0. And then when you change these values, even these values will change accordingly. And that is how you solve a Gauss elimination method, simultaneous equation using Gauss elimination method. I'll tell you the final values for this. X equals 2.2497, y is equal to minus 1.1244, and z is equal to 0.6247. I hope you guys have understood. We'll go on to the next method. Now we are going to see Gauss elimination method with partial pivoting. So what is partial pivoting? first we'll write these equations in the proper augmented form. I'm not writing everything right now. 2, 3, x is 1, 4, 9, this 10, 18, 16. Okay, so now in partial pivoting, what we do is we'll see this thing. From this, which is the biggest, like 2, 3 or 1. 3 is the biggest. So 3 goes to the position 1 from here. So this entire row goes to position 1 and this goes down at the place of 3. So we will rewrite it according to the partial pivoting. 3, 2, 3, 2, 1, 1, 1, 4, 9, and even this will change. So 18, 10, 16. So this is how we did the partial pivoting. And now what we are going to do is we will make this 1 by dividing this entire row by 3. So this will become 1, this will become 2 by 3, this will become 1, this will become 18 by 3. Okay, so now 2, 1, 1, 1, 4, 9, this line 10, 16. Okay, now we have to make this and this 0. Clear? This and this is to be made 0 like we did in the previous Gauss elimination method without partial pivoting as well. So let us go ahead and see how we can do it. So our R2 will be R2 minus 2R1 and R3 will be R3 minus R1, and that gives us 1, 0, 0, 0.6667 minus 0.3334. I've solved it before, that is why I'm not using calculator and solving it right now, but I've solved it before and checked the answers from the book, so don't worry. This is what we get. So now, which is the biggest term in this second column? 333 is the biggest number, right? That's the biggest value. So 333 goes to the second pivot position. So second pivot element will become 3.33333. So we just interchange this. This goes upwards, this comes below it, and then our equation, our augmented equation, looks like 1, 0.6667, 1, 0, 3.3333, 0, minus 0.3334, 1, 8, minus 1, 6, 10, minus 2. Now we will make this 1 and then this 0, and after that we will easily get the value of x, y and z. First we will get value of z, then we will get value of y from the value of z, and then we will get value of x. This is how we solve Gauss elimination method with partial pivoting. So now the question must be, why do we even need partial pivoting? So sometimes, not in this equation, but sometimes it happens that this element is already 0 and you want to make it 1. But how can you make it 1? If you divide by 0, it will go to infinity. And you cannot add something to make it 1. You have to multiply or you have to divide by rows only. You cannot just randomly multiply or divide by any number. So if this is 0, then this method is used. The largest number is taken in the first position of pivot element, and then the question is solved. I hope you guys have understood. So next up we are going to see the Gauss-seidel method. In Gauss-seidel method we have to check the diagonals, but basically we have to check the bigger elements. So now in the first column, 28 is the biggest element, so it should be in the first row, and it is definitely in the first row only. In the second one, in this column, 17 is the biggest element, so it should be in this position. So we will just rearrange it. 4y minus z equals 32. 2x plus 17y plus 4z equals 35, x plus 3y plus 10z equals 24. Now the rule what this is, the diagonal element should be greater than addition of the mod of these. So 4 plus 1. So mod of these, it is greater 17, it is greater than 4 plus 2 plus 2 or 2 plus 4, and 10 is greater than 3 plus 1. So here it is verified that this is correct. So we can use Gauss-seidel method over here. So we will separate the first row. This is our first row, plus 4y minus z equals 32. We will separate the x from here. So this will become 32 minus 4y minus z, and upon 28 equals 32 plus 4y minus z upon 28. Okay, for y also we for next second we do the same thing. 2x plus 17y plus 4z equals 35. So that is y equals 35 minus 2x minus 4z upon 17. And for the third row we will separate the variable z. So it would become z equals 24 minus x plus 3y upon 10. So yeah, this is what we have got right now. Now we will put x is equal to 0, y is equal to 0 and z is equal to 0. While calculating the value of x, we will put y and z equal 0. Then the value of x will come out to be 1.142857. Right. Then when we are calculating y, then we will put z as 0 but x this value. So some value of y will also come out. And then finally, while calculating z, we will put value of x and y which we have received, the new values that we will put over here. So for the initially it would be 0 0 0. Then for the first iteration it will be this new value, this new value and this new value. So now while calculating x for the second iteration, you will put value of y and z of the previous one. Then we will get new value of x, some new value that you have to put while calculating y, and z the old value. Whatever value of new value of x you receive, you put in z. So new value of x, new value of y in z, and you'll get new value of z. So I will suggest you that make a table at the same time so you can directly keep on substituting values, so it won't be a confusion later on. You have to solve it till the accuracy is achieved. Now what is accuracy? So you have received x ki some value first iteration, x ki some value in the second iteration, x ki some value in the third iteration. So the difference between these two, their mod should be less than whatever they have told. So 4 decimals, so 0.0001. It should be less than this, whatever value you receive, the difference between 2x. At that point you achieve the accuracy. Hope you guys have understood. I'm not explaining the entire problem, but hope you guys have understood how we have to do iterations. Generally we have to do 4, 5 or 6 iterations, but this question came for 6 marks like the last time, and one question came for I guess 10 marks as well. So if you do this correctly, it is very easy. You have to just go on substituting the values, nothing else. Okay, so now we will see Thomas algorithm for tridiagonal matrix. This is actually very formula based. That is why if you know the formula, you can easily solve it. First, these 4 equations are given. We will write that in the matrix form: 3 minus 1 0 0, 2 minus 3 2 0 0 1 2 5 0 0 1 minus 4. Okay, now x1 x2 x3 x4, and then 5 5 10 1, these values 5 5 10 1. Then these are the diagonal values. This is d1, this is d2, this is d3, and this is d4. This is u1, this is u2, this is u3, and this is l2, l3, and l4. So these are the values. I've written them down here itself. So now we will see 5 formulas. First is Li. Li equals Li upon di minus 1. Okay. Di equals di minus Li into ui minus 1. And Bi equals Bi minus Li into Bi minus 1. So now here n is equal to 4 only, because 1, 2, 3, 4. There are a total of 4 equations. And we have xn equals bn by dn. And we have xi equals bi minus ui into xi plus 1 upon di. So now we keep I is equal to 2, I is equal to 3, and I is equal to 4, and solve the problems. So now for example, we are solving for L2, D2, B2. Okay, so L2 will be as per this Li, that is L2 upon Di minus 1, that is D1. So that will be, what is D1? D1 is 3. What is L2? L2 is 2. So that is that would be 0.66667. So yes, that is our answer for this one. 66667. Okay. Now D2 is Di minus Li into Ui minus 1. So D2 minus L2 into U1. That would come out to be some value. This B2 will be some value. Okay. Similarly, we will have L3. We will calculate L3 when we put I equals 3. We will calculate L4, D4, B4. After we calculate B4, we have to find Xn. Xn equals Bn by Dn. So whatever value of B4 and D4 come, that we have to substitute here, and then we get X4, that is our Xn. Got it? Then for Xi, we do Bi minus Ui. For example, you want to find Xi plus 1 upon Di. So you want to find X2, so that is B2 minus U2 into X3 upon D2. So now D2, B2, U2, you already have, that you all have calculated, right? But X3 will be calculated only if you have solved Xi is equal to 3. Okay, and when you calculate Xi is equal to 3, you need Xi is equal to 4 for that. That is how step by step you start coming towards the answer. I hope you guys have understood. The answers here is x1 equals 2, x2 equals 1, x3 equals 2, x4 equals 1. But for this, it is very important that you know the formula. Otherwise, you cannot do anything in this. Okay, so next we are doing is the Taylor series method. In Taylor series method, this is our formula: yx plus h, y of x plus h, f dash of x plus h square by 2, f double dash of x plus h cube by 3, h cube by 6, f triple dash of x, and h raised to 4 upon 24, f fourth derivation of x, where h is our step size. So this is one problem which we can see over here. So we will just form a table, a small table with value of x and y. So we have to find y is equal to question mark when x is equal to 1.3, and the step size is 0.1. So first x is 1, then x is 1.2, then x is 1.3. and when x is 1, y is 0. When x is 1.2, we need to find out. When x is 1.3, y is question mark. This is our final answer over here. So let us see how we can go ahead. We will need y dash, y double dash, y triple dash, and y fourth root. And then in that we will put x 0 equals 1, y naught equals 0. In whatever the roots, whatever the answer we get over here, we will put x naught equals 1, y naught equals 0. And then whatever those values we get of y naught dash, y naught double dash, y naught triple dash, y naught fourth root, that we substitute in this equation, and then we get value of y1. Now this is our step 1. We need to do a step 2 as well, where y 1.3. So x is equal to 1.3 and y is equal to question mark. Here what we did, x is equal to 1.2 and y is equal to question mark, but that y we got question mark wala after solving. Here same thing, x 1.3, but x naught here will be 1.2 and y naught here will be the value we got from over here. And then we do these same steps. We substitute this value of x naught and y naught in this equation, the derivatives one, and we finally get the value of y1, and that is our final answer. But making a table here makes it a lot more easier to understand what exactly we have to find. I hope you guys have understood. Let's go to the next method. Next up, we are seeing Euler's method. In Euler's method, this is the only formula: y1 equals y naught plus h into f of x naught y naught. So we will see this word problem. This has previously come in the exam. So we will just substitute t as y over here, and q is given as 1000. Okay. Moreover, so q by a is given as 1000 over here. Let us go ahead and write it like t is y, dt by dx 1000. So dy by dx equals minus 1000, 1 by 0.5 into 0.01 y plus 1 bracket close. So this is how our equation looks like right now. Okay, so here x is 4 centimeter, that is the final thickness, and step size is 4 centimeter over here. So this is step size, x is equal to 4. The final is 20 and step size is 4, and it starts with 0. So it will go like 0, 4, 8, 12, 16, 20. But one thing, if you would have noticed, then this is all in centimeter, but we have to find it in meter square. So we will just convert it to meter. 0.08, 0.12, 0.16 and 0.20. So these are our values of x, how x is varying in this. And for y, they have told temperature is 500, and we have to find till this. Now what are we going to do over here? We have x naught and y naught here. X naught equals 0, y naught equals 500. We will simply find f of x naught comma y naught, which is this. A minus is also included, which is this. We will substitute 0 and 500 over here in this equation, and we will get some value. Here the value we are getting is minus 333.333. And how will we find y1? It is equal to y naught plus h into f of x naught comma y naught. So this value into step size, which is 0.04, and value of y naught, which is 500. So this is So here our answer y of 0.04 is 486.6667. Okay, so now in the next step, this was the first step, we have to go till here. So you will have to find y 0.08. Here x naught will be 0.04 and y naught will be 486.6667. Then you have to do same thing, you have to substitute this over here and then calculate y1 equals y naught plus h f x naught comma y naught. I hope this is clear. Actually it is very easy, so I hope you guys must have understood. If it was not visible on screen, the PDF will be uploaded on Drive as well, so don't worry, you can refer to the PDFs. We'll go on to the next method. So here we are looking at Runge-kutta Runge-kutta fourth order method. In this there are four values k1, k2, k3, k4. We have to memorize it. K1 equals h f of x naught y naught, k2 equals h f of x naught plus 0.5 h y naught plus 0.5 k1, k3 equals h dot f of x naught plus 0.5 h y naught plus 0.5 k2, and k4 equals h into f of x1 y naught plus k3, and then k is equal to k1 plus 2k2 plus 2k3 plus k4 by 6, and then value of y1 is y naught plus k. Okay, so we will see, this is our question and this is our equation. So we will just rewrite it, dy by dx equals 2 minus xy. So here they have told कि we are given that x is equal to 5, y is equal to 2. So in the table x, y, 5 and 2, and it has a step size of 0.05 and we have to find till 5.1. So it will go like 0.5.05 and 5.10, and then these two you have to find. Now how will you find y when x is 5.05? You will find value of k1, k2, k3, k4, whatever it is given, x naught plus 0.5 into h. So now you know h is equal to 0.05. So those values you will find out and substitute in this equation. Then you get values of k1, k2, k3 and k4. And then you calculate k out of that. Then you simply add y. 5.05 would simply be y naught, which is given over here 2, plus whatever value of k you get. And that would be your answer. In next step, in step 2, you will have to take x naught as 5.05 and y naught as whatever this value will come, and then you have to calculate y when x is 5.10. I hope you guys have understood. I'm doing it like a very quick revision kind of thing because there's very less time left right now. So sorry if you are not getting anything. Okay, so now we will see Runge-kutta second order method for simultaneous differential equations. So how does it work? It is basically used to solve simultaneous equations. So this is k1, k2. In Runge-kutta fourth order method, we had k1, k2, k3, k4. Here we just have k1 and k2, but we also have L1 and L2 because these functions are functions of x, y and z. So we will see from this example. I'll explain one step only, so then you'll understand it because it's very easy. X, y and z is there. So your x is 0.02. They have said that x is 0.2 towards the end, y naught equals 2, z naught equals 0. So at when x is 0, y naught is 2 and z naught is also 0. And then they have given step size is 0.1. So this is question mark and then 0.2, you have to find it. So you have to find it. So this and this is your final answer for y naught and z naught. So we will see how you go ahead with this basically. First, k1. K1 is h into f of x naught comma y naught comma z naught. So these three values you have to put over here. So what is essentially f of x naught comma y naught comma z naught? That is this equation, the first equation z. So it is like 0.1 into f of 0. That is 0.1 into 0 is equal to 0. Similarly, you have to find value of k2. Here you find value of L1, here you find value of L2, and then y1 equals y0 plus k, and z1 equals z0 plus k, or z0 plus L. But what is exactly k? K is equal to k1 plus k2 divided by 2. L is equal to L1 plus L2 divided by 2. Now whatever value you get for y1 and z1, those will be z0 and y0 for the next. So next x is equal to 0.1, y is equal to, y0 is equal to this new value, z0 will be this new value, and you solve again, and whatever answer for x and for y and z you get over there, that is your final answer. I hope this is clear. We'll go on to the next method. Okay, so now we will see Runge-kutta second order method for simultaneous differential equations. So how does it work? It is basically used to solve simultaneous equations. So this is k1, k2. In Runge-kutta fourth order method, we had k1, k2, k3, k4. Here we just have k1 and k2, but we also have L1 and L2 because these functions are functions of x, y and z. So we will see from this example. I'll explain one step only, so then you'll understand it because it's very easy. X, y and z is there. So your x is 0.02. They have said that x is 0.2 towards the end, y naught equals 2, z naught equals 0. So at x when x is 0, y naught is 2 and z naught is also 0, and then they have given step size is 0.1. So this is question mark and then 0.2, you have to find it. So you have to find it. So this and this is your final answer for y naught and z naught. So we will see how you go ahead with this basically. First, k1. K1 is h into f of x naught comma y naught comma z naught. So these three values you have to put over here. So what is essentially f of x naught comma y naught comma z naught? That is this equation, the first equation z. So it is like 0.1 into f of 0. That is 0.1 into 0 is equal to 0. Similarly, you have to find value of k2. Here you find value of L1, here you find value of L2, and then y1 equals y0 plus k, and z1 equals z0 plus k, or z0 plus L. But what is exactly k? K is equal to k1 plus k2 divided by 2. L is equal to L1 plus L2 divided by 2. Now whatever value you get for y1 and z1, those will be z0 and y0 for the next. So next x is equal to 0.1, y is equal to y0 is equal to this new value, z0 will be this new value, and you solve again, and whatever answer for x and for y and z you get over there, that is your final answer. I hope this is clear. We'll go on to the next method. So we are almost towards the end of the video. This is simple Laplace method. In the simple Laplace method, you are given a mesh, and in the book they have given LR, LB, LC, whatever. I have a very easy concept of this. So if you want to calculate U1 over here, you just write 1 by 4 and then you write 1000 plus 2000 plus U2 plus U3, that is 1000 plus 2000 plus U2 plus U3. Okay, now if you want to write U2, so you write from in the plus sign whatever is there. So U2 equals 1 by 4 1000 plus 500 plus U4 plus U1. U3 will become 1 by 4 2000 plus U1 plus U4 plus 500, and U4 will be 1 by 4 U2 plus 0 plus U3 plus 0. Okay, so this is how you just write the values of U1, U2, U3 and U4. Now the next part is you substitute U1 as U1, U2, U3, U1, U2, U3, U4 equals 0. Okay, so now here you put U2, U3 equals 0. You find some value of U1. Whatever value of U1 you find, you put it in the next part, next U2, solve it, and then here U4 will be 0. Next value of U2 you find, you put in the equation of U3 or U4, whatever is next. So whatever new value you are obtaining, you are supposed to substitute in the next steps, as long as you don't achieve the accuracy. So here accuracy means the difference between value of U1. So in step 1 your U1 is something something, in step 2 your U1 is something. So their difference mod of their difference should be minimum. That is your, so if accuracy is given 1, then it should be less than 1. If accuracy is given 0.1, it should be less than 0.1. Until the accuracy is achieved, whatever your difference between these two values is, two consecutive steps, if it is less than accuracy, then and then only you can stop. If it is, so if the accuracy is given as 1, the difference between the two values of U1 and U1, so U1 from step 1, U1 from step 2 should be less than the value of 1, then and then only you can say you have reached the accuracy and you can stop the solving. Okay, at the end you have to form a table for this as well, U1, U2, U3, U4 and iteration. So that is 1, 2, 3 till you achieve the accuracy. So till the difference here is less than the accuracy. So we'll go to the next problem, next method. That method is parabolic explicit solution. So in that there are boundary conditions given, and there is an equation, differential equation, and you have to calculate. So whatever it is given over, so this is our equation. So that is du by dt equals d square u by dx square. This is the equation given over here. Now what you have to do is, here there's something called a. So here a is equal to 1, essentially a is equal to 1. You calculate the value of c, a is equal to 1, k. What is k? K is the difference in time. Difference in time is k. So that is 0.02 over here, and it is 0.2 ka whole square. So whatever value of c comes, it is 0.5, which is less than or equal to 0.5. So we can use Bender-Schmidt for method over here. Now what is Bender-Schmidt formula? in Bender-Schmidt formula, you write the values of x, you write the values of t, and then you, so this is in one column itself. My bad, I have not written it properly. So here values of t, here values of x. Okay, so this is value of x. They have given that x is 1, so final x value of final value of x is 1 and h is 0.2. So it will go like 0, 0.2, 0.2 plus 2 is 0.4, 0.8, etc. And value of t will go along like 0. T will be also starting with 0, 0.02, 0.04, etc. So value of t will go as 0.02, 0.04, 0.08, and etc. as we go ahead, and then finally 0.1. So we'll consider till 0.1 only, and this will go till the end 1. Okay, so what we are going to do next is, when x 0 comma t, it is 0. When 1 comma t, it is 0. So when x is 0 and u is when x is 0 and x is 1, value of the entire equation is 0 only. So in this column we will fill 0, 0, 0, and in this column also we will fill 0, 0, 0. Now we have these values 0.2, 0.4, 0.8. So this equation sin pi x, here we put x is equal to 0.2, x is equal to 0.4, x is equal to 0.6, x is equal to 0.8, and whatever value comes from this, we put it in these respective places. After that, this u1, u2, u3, for u5, u6, u7, u8, u9, u10, u11, u12. So 6, I missed 6 over here by mistake, but no worries, I missed 6 over here. But the thing I want to explain is, see here u1, the value of u1 will be calculated as 0 plus this value, whatever this column has, divided by 2. Whatever this value of u2 will be calculated as this column, this cell plus this cell divided by 2. Similarly, if I would have written 0.6 over here, its value, the value in this cell would have been this plus this divided by 2, and u3 is this plus this. So just, it's like, if this is one cell, this is one cell, you want to find out its value, you just add this and this and divide the entire thing by 2. That is how you so what I was telling is, if you want to find this value, then you add this value and this value and divide it by 2. That is how you get the values. And in this problem, we only have to fill up the table with the given values of u1, u2, u3. So first table will look like with all the values u1, u2, u3, and then the final table will have all the proper values which we would have find out till the end. So these were all the methods to explain. Next we'll go to the flowcharts. I'll be only explaining, I guess, 3 or 4 flowcharts, not more than that, because they are the easiest and it's already very late. So I think it would be best to do the easier ones first. So the flowchart you can see on the screen is for Runge-kutta 4th order method. It is a very easy flowchart according to me. It just has a start, define function f of xy, then you have to enter the values of x0, y0, xn and h. After that you define n, which is the number of iteration, which is final value of x minus initial value of x divided by h. After that we put a for loop and we write all the formulas for Runge-kutta fourth order method. That is what is x1, what is k1, k2, k3. Here they have written k4, but we have to write here they have written kn, but we have to write k4 over there, and then k, the formula of y1, formula of x0, x0 equals x1, y0 equals y1, and then simply print. And over here, as you can see, if I is not from 1 to n, if n exceeds the given value, so if n is equal to 5 and then n is equal to 6, then it doesn't run further, it just ends. So I think this flowchart is very easy. This is another flowchart which I found very easy. This is for Euler's method. You start, define function. It's similar to Runge-kutta second order method. Then you write in, then a for loop, then all the given formulas, and simply print function. If it is not between, like if it exceeds n, the value of n, it will go to no and then stop the function. Here the lines are attached and that is absolutely wrong. This first line, like this line which starts from print, does not touch the line which starts from no. Okay, so print happens continuously till value of n is not exceeded. When value of n is not exceeded, then it goes towards the stop and the function ends. According to me, it is very easy. So this is a flowchart of Runge-kutta second order method for simultaneous equations, and even this is very easy. First, only difference between this and Runge-kutta fourth order method is you have to define function f of xyz and g of xyz, and then you have to write all the formulas k1, l1, k2, l2, kl, y1, z1, x0, y0, z0. Finally print when value of n will exceed the given value of n, then the function, the program will end itself and you will get the final answer. According to me, this is also very easy, and this came in exams in May 2018. So I think there are chances that this might come this year as well. So this is all for today, guys. If you're watching till here, thank you so much and all the best for your exam. Good night, everyone.